Good evening, everyone. This is usually what happens when you have the last session in the day, but it's okay. Looks like a private lesson to me. So okay, let's see what we get out of this. So I came from Lulu, so like 900 more kilometers from the north to talk to you about this research. So this is a bit of a different flavor maybe from what we have seen before. It's not a product, but we have plans to productize this research. So I'm working on this research with a colleague of mine at the department. He is an industrial PhD candidate. Okay, so this is the agenda. So I'm giving you the context about this research and the story, and then I'll talk about enterprise systems. I'll talk also about the life cycle, the problem that we try to investigate further in this research, and some of the results that we'll share with you. And in the end, we'll talk about some little giveaways that might help some people here in the room to address the similar problem. So what is the story of this research? So the research is related to that PhD candidate I talked about and myself, because we both have been doing consulting research, consulting activities with companies. So, and then we kind of discussed this scenario that we felt that we have to do something about this. So the scenario is like the following, that when you implement an information system, so many people in earlier presentations talked about implementation. Then a lot of businesses feel like, okay, we are going to have some rest after the go live. So the system started to be used in action, but nevertheless, this is not usually the case. Because after implementation, what happens usually, that you have some sort of setbacks, you have problems, you have lack of availability of these systems, and then you start also to address these problems further. So we thought about this problem and we thought to do something about this. So this is, the motivation here was like, we worked with organizations, so once the system is live, then many of them started to suffer from lack of availability. And then they have SLA. If you want a better service, you have then to pay more. That SLA would cost you then furthermore over your budget. And then there is a delay between the time that you face the problem with your system until the vendor or the SLA provider comes back to you to address the problem. And in between those two times, the business might stop, or at least part of it. So this is the story behind this kind of research. So we thought to do something, and this thing that we have done is the so-called here AAE for Advanced Analytics Engine. So our idea is like the following, that we design an advanced analytics engine, and that engine works on reading multiple sources of data, and then analyzing these data sources, and then try to project what kind of business function or business process will stop, or any kind of service of the system, and then suggest a solution, and then try out the solution, and then probably also fix the problem. So this is the idea. And that advanced analytics engine, it will sit on top of the system, and therefore it will monitor the system, not only from system log or application log, but also from tickets, from forums, from documentation, PDFs, and history between the business running the system and vendors, as well as service providers, especially SLA providers. So this is the context of this research. So to give also more explanation to the scope of our research, so that we maintain think. So we talk about enterprise systems. Enterprise systems are kind of large system that usually span the scope of a single process. So usually support organizations in cross-functional manner. And these systems are found in a majority of the organization. It's actually hard to find a business that does not run at least one of those systems. So the type of systems here are pretty much, but one of the classification is like this. So we have ERP systems, CRM, SCM, KMS, and others. And the important thing about these systems that they keep critical information about the business, that if we have a failure on which, then part, like I said, part of that business might stop for a while, depending on how fast or how high the SLA is for the business. So they have organizational data, transactional, master data, and therefore they need to run without a stop. So we also have a focus in our research. So we looked at the life cycle of these systems, and then we need to distinguish between those two, as you can see. So the development and then the implementation. And then our focus was related to the implementation. Actually, the implementation, as a matter of fact, has also multiple phases, as we will see. So we would rather focus on the implementation rather than the development, because the development is in a software house. So there is no business, there is no organization in place. So, and therefore, we decided to focus on implementation. If you also look at the implementation life cycle on its own, then we have those phases. So they start where a business or an organization decide to adopt one of these enterprise systems, and then they acquire it. Once it is acquired, then we have a project, and then the project runs through the implementation. And then post the implementation, then when the system is live, implementation is now successfully finished. So we maintain these systems. System evolve over time. Probably we upgrade, we fix these systems, and then maybe in the future we might need to retire that system. Retirement here does not mean that we completely get rid of it in a certain business, but rather we replace it with another one that is probably more fitting the needs of that business. So we focus on the life cycle activities post the implementation. So what happens post the implementation? Like I said, so now we are live. That means that the system now is running the business. So because these systems have, like I said, wider scope. So what happens of these operations post the live? What kind of operations businesses need to encounter or face? So they maintain these systems. So this is one of the activities. These systems need to evolve as per the dynamic needs of the business as well. So upgrade/retirement, support, performance of these systems, and also productivity of employees working on these systems. So as you can see here, pretty much of operations that we need to take care of once these systems are live. So and that also means for us, like, live is not the end of the story. So there is another journey that businesses go through once they are live. So what is the problem post-live? The problem, like I said, is like the following, that we are now live, so we rely on these systems. So we try to maintain these systems live as much as possible. But the bad news is, like, this is not usually the case. What happens usually is, like, you have some sort of downtime. So the system is not working. So you have a problem, the system is stopping to support some services, some reports, some business processes. If the case even might be intensified if these business processes are kind of customer facing or part of a certain kind of compliance that the business should admit to or follow. So we thought about addressing these problems via machine learning techniques and big data. And then I will show you the nice part about this. So the solution that we designed is, like I said, we called it Advanced Analytics Engine for AAE. So this is our system from a high level. So how it functions, if you look at the left-hand side, we have plenty of data here. So we have to look at the business blueprint, if the term is not common for us. So in a nutshell, so when an enterprise system is implemented for an organization, so it is customized to fit the need of that business. Then we create documents. Those documents are called business blueprint, that they map the components of that enterprise system to a specific organization. So this is a business blueprint. Then support tickets. So these are the tickets that are created post-live. So when an organization is live on a system, so they have a problem, then they have a vendor or a partner with whom they have the SLA, then they create a ticket, and that ticket, based on its priority, then it gets resolved. Sometimes it takes longer, sometimes it takes shorter time. So, but this comes over time like a history, so the support tickets. And then there are also forums where customers and partners and then the ecosystem of those enterprise systems talk to each other. So you can post any question in the forum. Of course, here you don't have any kind of like fast lane to response. You will wait until somebody answers you. We also have emails exchanged between the organization implementing those systems, their vendor, their partner, the consultants, the IT, and help desk, and there is a lot of society here, members. and finally the documentation of the system. So if you wanted to look at problems and how they have been solved, then you need to look at those data sets on the left-hand side. So in addition to, there is a very also key part of the data set here, which is the application log. So on here, I don't want to go into technical details, but it's very simple, looks like this. So when you have a failure in a system, usually there is an application log, and the log takes certain parameters. Before the failure, certain parameters are read and stored on the log. And then if you wanted to understand how the failure happened, you then need to have like a window. So probably you need to read the log every, probably, let's assume 1 minute. So you need it for 1 minute, second, third, fourth, fifth. So you have a window of like 5 reads. Before any failure, if you look at that log, you would find a certain pattern prevailing before failure. If we can understand that pattern, we will be able to predict the failure. So this was the idea here of looking at the log files of the application. Then we have the analytics engine sitting on top of that enterprise system. And then we have the three phases of that analytics engine. One, to try to detect the problem either manually, but a user is flagging, is raising concern or writing a ticket. And the second one is automatically. So nobody is complaining, but the reads of the log tells us that there's something happening. There's a problem in the making now. So this is phase one. And then phase two is to try to suggest a solution. And then phase three is to try to confirm the solution. You try out the solution, make sure it is working, and then enforce it so as we might be able to, one, avoid the failure, or two, solve the problem. So these are the components of the analytics engine. So our objective is to operationalize this analytics engine into post-implementation phases. So once the system is live, this engine sits on top of the system so as to help with those two objectives, like I said, to predict and fix problems. That will happen so that organizations will never run into a situation where the system is not available. So this is the ultimate objective. Yet at a cheaper cost, of course, because you don't here need to have an SLA. So we'll show you some of the results that we have gained, but first to talk about the phases. So what are the phases? When you wanted to design this analytics engine, you have to acquire the data. Like I said, the data is too much actually, so we have plenty of sources, and then you have to pre-process the data. And keep in mind that many of these sources are in text, and text is great, but it's not really usually ready for computational consumption by algorithms, so that you have to apply a lot of pre-processing to this text in emails and in PDF documents, the blueprint documents, the documentation documents, the forums, etc. So pre-processing is a substantial task here in terms of effort, difficulty as well. And then we apply the analytics, and then we make sense of the analytics. So this is where we wanted to enforce a suggested solution. So as I said, the acquisition here, we get the data from the business blueprint, BBP, and then support tickets, problems happening, emails exchanged between the different stakeholders of the system, documentation of these systems, application log files, and also failures. Pre-processing depending on which kind of source of the data that we are talking about. But as I said, many of these sources have been text, so that we have been able to apply different text analytics, as you can see on the left side here. So of course, plenty of details here for those interested. You might want to contact me later if you wish. And then also discretization of the data, looking at filtering of cases, splitting the data, training here and testing, etc. So this is the pre-processing. And then I wanted to show you some and share with you some of the analytics results here that we have gained. So one of which is that we have been able to tokenize documents, source documents. We look at the document as a bag of words. So we tokenized the documents. So these documents here representing the business blueprint. So you have, for example, the sales function is described of a certain business is described in a document. So we extract the knowledge from that document describing the sales function of that business, and then we try to make sense of it. We also try to link that document to other documents. What for? If we are able to link documents to one another, then we will be able to cluster the knowledge about a certain topic in a certain area, and later on apply a different technique so as we are able to extract solution knowledge from the relevant documents. We cannot start from the point that we look at all documents at once. So this was a kind of a prerequisite step that we are able to calculate the distance between documents, and hence segment documents like previous presentations talked about clustering and segmentation quite often today. The other thing is like we have also been able to recognize what document is this. And then we have applied testing as well, and it was 100% successful actually in that scenario. That when the analytics engine reads a document, then the analytics engine is able to tell this is the sales description of the process in a retail store. This is the manufacture of an automobile industry, and so forth. So we are able to read the document, process the text, categorize the document. And this is very important. You might think, oh, this looks like simple. Yeah, but when you look at the context of how to use it, it's not. Because now when I have a sales problem, I look at only sales documents. If we cannot tell which documents are related to sales, then we have a problem in automation of this solution. So we have been able to identify documents in different examples, like here MM for like material management. So this is part of an enterprise system here related to purchasing, to sales as well, to HCM. So we are able now to look at the document and classify it, know what kind of document is this, and also classify it. We applied different other analytics techniques as well. So we have been able to detect a kind of a common problem in a year. So this is sort of a kind of an automated evaluation of the system. That, for instance, you realize that there are kind of too many problems related to maybe manufacturing in a year, in a certain year. And that will give a clue on probably the quality of implementation, or maybe the quality of utilization, the efficiency of use. So these are things that are byproducts when you know what was prevailing on a certain year. Department and ticket description as well. We have been able also to understand the way certain departments in a certain organization get used to describe the problem. So now later on when I see a problem is described usually in a ticket, support ticket. So when I see the ticket, when the engine reads the ticket, the engine is able to say this is coming from the production department. This is important so as to save the time in the search space for solutions then. So these are kind of results of this. We also apply topic modeling. I'm not sure if it is familiar or not here, but it's one of the advanced text analytics techniques. So topic modeling is able to tell us when you read documents what kind of topics these documents are talking about. So the nice thing about this, so these are 10 topics that we extracted with also word probability. What are the common words in documents? And we have been able to marry these topics from problems with topics from solutions. So this was really good and helpful for us. And then we also validated this kind of findings, and then we realized that it's about 80% of the time we are able to link a topic talking about in the problems to topic talking about in the solutions. And this is really helpful to the engine, that it is now able to link a problem to a solution. And this is part of the objective to automate this solution of the problems. We also have been able to link a ticket to module. This also is important to, once again, optimize search space. So when we read a ticket, so we have applied this to history of tickets. It was like more than 5 years of tickets in the history that when we read the ticket in an automated fashion, of course, we are able to tell that this ticket belongs to that module. Of course, even if the module is not written in the ticket, that also will help to optimize solution time. So we use different techniques like general linear model, neural networks, decision tree, as you can see here, and this is the accuracy. Accuracy here is not that high, but for the other, it is rather higher here. So we can link also ticket to technician. This also helps us to quickly find the solution. As you can see here, accuracy is very high on those 5 years history. So that for the neural network and the GLM have been able to find this accurately 90% plus of the time. User to module is the same as well. User to number of tickets, we can project how many tickets this user would create in a year. This is not only helpful in understanding the ticket and the solution, but also in capacity management as well. So how big is your, for example, support team with the root mean square error as a measure of accuracy here. In progress, still in this research, we're trying to predict failure, like I said, with this 5-minute time window, to integrate the solution with a chatbot, to fully automate the data acquisition and the processing, and also integrate it with multiple enterprise systems rather than the one that we currently are testing it on. And takeaways in the end, this is the last slide from my side, is employing advanced analytics has the potential to support post-live activities. This is helpful to companies in 2 ways, that you reduce failures and increase availability. Of course, so this is an objective that each organization is looking after. And second is to reduce cost of support. So this will enable businesses to rely less on external vendors and to automate this process, and hence making their systems available much more. And in the end, again, like I said, if we are also able to automate this failure detection, failure fixing, and also closing this cycle of that failure detection and fixing, then that could have been also a situation that all businesses are looking after. With that being said, this is the end of this presentation, and thank you for listening. Thank you.
Before we move to the networking cocktail, does anybody has a question? All thirsty? Good. So with this, we conclude the business analytic stage. The closing of the conference will happen in the data octagon. Some refreshments and food has been served. So those of you who would like to stay a little bit longer, it will be our pleasure actually to have you here. Yeah. Thank you for today, and I hope it was at least worthwhile.